The alignment instructions for this radio are right on the first page of the Sam's Photo Fact. The first thing we're going to be doing is peaking the IF coils for 455 kilohertz. They say to attach the high side of your signal generator to the grid of the 12SA7 and the low side to common, and to use a dummy antenna of 0.01 microfarad. What that dummy antenna is, that's simply a capacitor in series with your signal generator and the tube. Turns out that high side of the 12, or the input of the 12SA7 they're talking about, is pin 8. So I have tacked in that capacitor to pin 8. The other end is going to the output of my Leader 17A RF generator. I've got it on the B range, which covers 455 kilohertz. And they conveniently put a little tick right there on the scale, so you can dial in 455. Now this is a hot chassis set, or actually more accurately, I should say it's a floating chassis set. The negative side of the circuit is actually this black and white striped wire you see running throughout the set. And conveniently I found a spot right here to clip on my alligator clip to the black terminal on my RF generator. I have turned on the internal modulation. Now, as for reading the output, I'm using a VTVM. It's an RCA Volt Ohmist WV77E. They say to connect your meter to the voice coil, but I had trouble getting a decent reading, so I'm actually going on the other side of the output transformer, on the primary side. So right across pins 3 and 4 of the 35L6 audio output tube. That's what these two clips are down here. Now what you're supposed to do is crank up, first you're supposed to tune the radio so that the capacitor plates are fully closed, maximum capacitance, which means the scale's all the way at the far left and the capacitor plates are fully meshed, fully closed. So we're there. And you're supposed to crank up the volume all the way. And as you can see when I do that, the meter deflects. Now that's just kind of background noise and hum I'm picking up. Now I'm going to increase the output level of my RF generator. Can you hear that? So I want to use a low enough level so that I can pick it up with my meter, but I don't want to peg the meter, so say right about there. Now I want to go through and peak the IF coils. Those are these screws here, 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 and here. I've got a plastic alignment tool with a metal slotted end. I can fit into those coils. And simply go through all 4 to get a maximum meter deflection. There. I'll drop my signal level down. So this one was off by quite a bit. Next coil. And here's the last one. This one was pretty much dead on the way it was. Alright, and that's it for the IF. So, does it work any better? Well, let's see.
I szpitali. Zdanie polegają na tym, że płacimy do
Mention this program and you're going to get a risk-free trial of
Now, to be fair, the coils weren't really off much to begin with, so I wasn't expecting much of a difference, because it was working quite well as it was. But it certainly doesn't hurt to go through the procedure, and it's pretty simple on a radio like this.
Well, there's the facts that you're going to feel right away that you'll notice. It's not just a whole... Cardinals red. Now this is a team.
Okay, here's a demonstration of how you could visually align this radio. I'm using an RCA WR50B swept RF generator and my Hewlett-Packard 54600B oscilloscope. You don't need a fancy digital scope like this at all, it's just the one that I happen to like using. So just as with the fixed RF generator, I've got my output going to that same 0.01 microfarad dummy cap, to that same grid on that tube there. And the negative lead is going to common on the radio. What this will do is it'll sweep frequencies from around 400 to 500 kilohertz, I believe. So it's got two dedicated sweep modes here. One for AM radio, 455 kilohertz, and the other one for FM radio, 10.7 megahertz. It'd be really nice if I had a 455 kilohertz crystal that I could stick into that socket, which would put a little blip on my scope when the sweep generator hit exactly 455. I do not, so what I rigged up is I took my Leader 17A output through a small mica cap and fed it into the radio. This will heterodyne with the sweep generator and make a blip of sorts on my scope. So here is what I see on my scope. I'm using a demodulation probe, so I'm actually seeing the envelope of the output of the IF stages rather than the actual modulation envelope. Makes a nice clean signal to look at. If I decrease the time base, we get multiple instances. So it's sweeping from, say, 400 to 500, and then 400 to 500 again, and on and on and on. Now, something I glossed over a bit when I did an earlier video on how to visually align a radio is how exactly I'm driving the horizontal on this scope. See, most sweep generators, like this WaveTech and this guy, have a dedicated horizontal output that goes to your scope, and you got a vertical output that goes to the scope. Horizontal output drives the electron beam back and forth this way, and the vertical goes up and down. Sometimes that output's called the CRO for the cathode ray oscilloscope. Well, this sweep generator has no horizontal output. In fact, all you get is an RF output on this. So what they intend you to do is to actually drive the horizontal off of the line voltage. Because the way these work is there's a varactor diode inside. A varactor diode is a device whose capacitance varies with the voltage applied to it. Well, you stick that device into a tank circuit, an oscillator circuit, and you put a varying voltage on it, and there you go. You now have a variable frequency oscillator. Well, they could have driven that with like a sawtooth generator and then given you a nice sawtooth output here. You could go to the horizontal input on your scope. Instead, they are actually running that from the line voltage. So it's a 60 hertz sine wave that's going onto that varactor diode. So what I'm doing is I'm actually triggering off the line. So imagine superimposed on this a 60 hertz sine wave coming right off of the AC line voltage, and my scope is triggering, say, whenever that hits its peak value, which does give me a stable synchronized input, but the horizontal, the linearity might not quite be so kosher, let's say, as a sine wave is not linear, and I'm driving my scope's horizontal with a linear pulse, so it gets triggered by a sine wave, but then the internal scope takes over and makes a linear sweep, so it gets a sync pulse, then horizontal sweep. But because we're just peaking the IF, the actual shape of this envelope doesn't really matter. If I was aligning, say, an FM radio or something where I wanted to get a really accurate depiction of the IF response, this wouldn't be a very good setup. If I wanted to see a really accurate representation, I would try to tap into this device, or at least use something like a variac, so I could get a variable AC voltage that's derived from the line, and hook that up, the output of this, to the horizontal input on my scope. At any rate, here's what I've got. This is the IF response of this radio. Now, if I take my leader and fiddle around with the frequency knob here, I can get a marker of sorts. It's a little squiggle that's down here right now. I'm increasing the amplitude on it now to make it a little more obvious. So, that little squiggle there, that is the marker. So I have my RF generator right now on about 450 kilohertz. So that point right there is about 450 kilohertz. If I go over to 455, right about there, now that marker is like right on top of the response, which is making it all crazy. When you use higher frequencies, markers get a lot more distinct than they do at these lower frequencies. And like I said, if I had a crystal, this would probably be a lot more distinct, but that's what I got for now. So I'm going to drop that level down. Now the idea is, you use this marker to know where along this sweep your 455 is, and you want to make a maximum response where you've got the marker. So I'm going to set my camera on the tripod, and let's see what happens when I tweak the IF coils. Now, if I didn't use a marker, I could theoretically give this a peak response at something like, I don't know, say okay. Now, if I didn't use a marker, I could theoretically get a peaked response at a different frequency, like say 400 kilohertz or 500 kilohertz. Okay, still see the marker there. I just dropped the level down, so there's just a little blip right there at the top of that peak. Now, if you didn't use a marker, you could end up peaking this for a different frequency, like say 440 kilohertz or 470 kilohertz. It's a good idea to put it on there. I'm putting my alignment tool on the top one of the slugs here, and if I tweak it. So you get a dramatic alteration of the IF response. So now because I already aligned this with the RF generator and VTVM, these are all probably going to be pretty much dead on, but we can go through it again. So there was one. Also, very dramatic difference when you work with these. That's because the sweep generator has a pretty small sweep range. In fact, it's probably not even going as far as 400 to 500. Well, I guess I can answer my own question since I've got this marker generator, so let's see. Drop this down a little. So I want to know what's the frequency over here, what's the frequency over here. Alright, so it looks like we've got frequency over here is around 435. On the other side, about 480. So it looks like this is sweeping from about, let's say, 430 to 480 kilohertz. Alright, 2 more slugs to go. In case you were wondering where I had the scope demodulation probe hooked up and where I was injecting that marker, I had the demodulation probe hooked up right here, which is the output of the detector, and I was injecting the marker right here through a 47 picofarad cap. Yeah, still works just fine. So last few things, I do want to break open an electrolytic can and restuff it. And I want to clean this up a little bit. The chassis looks to be rust free, just a little dirty, so I'll use a damp cloth and just wipe it down. And this glass dial face here is quite dirty on both sides. So I'm going to carefully use some Q-tips and clean that. I know on some old Philco radios from the 30s, they used water-soluble ink on their dials. If you try cleaning them with like Windex or even just some water, you can actually wipe the ink off. So be very careful with this. For those radios, I've heard that mineral spirits work fine. This is a radio from the 40s, different company. I suspect it's not water soluble, but we'll see. I'll clean up the knobs and then buff the cabinet out, I guess, and that'll be about it.
The sign of the Lord, and He shall lift you up. This 17 seconds, it just burned me. You guys are going to create your own storyline. People are going to kill like to a 2-dog family.
Now, let's see if I can get this old dial off. It's a piece of glass. It's actually painted on both sides, I think. It seems to be held in by rubber on either side, which has gotten kind of brittle. See, okay. Seems to be more or less separated from the glass. Oh, I see. If you just bend away the top, you can slide it out. And then I guess the rubber is actually glued down to the metal underneath. Alright. You can see how filthy that is. So is the metal underneath. Appears to be either copper painted or copper plated steel. This dial pointer, looks like some of the red paint is flaked off of that. And it looks like this dial pointer sat here for a very, very long time. You can see a mark on the dial glass too. Looks like this was set on WGN AM720, maybe for decades. I'll see if I can clean that off. I've been using this blue glass cleaner, very carefully applied with a Q-tip, and it's working just fine so far. I've done the right side there. Still want to go over it a little bit more. You can see it's much cleaner already. And it hasn't harmed the paint at all. It took a little while, but slowly all the old dirt and gunk came off. Except for that discoloration around AM720. So what I ended up doing is taking a very, very small amount of Novus number 2 on the end of a toothpick, and I've been rubbing away at it. I just about got it all off. Just a little bit left right in here. A little more rubbing and I think will be all gone. Alright, that cleaned up quite nicely. Now, for the piece of plastic that goes over it, which is also quite dirty, I'll use some glass cleaner and then Novus number 1, and we'll see how it looks. Hopefully that'll be good enough. If not, use some Novus number 2. I was surprised to discover that the Novus number 1 actually made it cloudy. This normally works great on clear plastic. So I just went over with Novus number 2 and started cleaning some of it off, and that seems to be doing the job much better. I cleaned up this dial back plate as best I could, but you can see how it's corroded here and the paint's worn away from the dial pointer sitting there for so long. So I am going to carefully remove this. It's just held on by a nut here and a couple screws, and repaint it. I'll also have to carefully get these off, which are kind of coming off already anyways. And then I'll prepare this, sand it down a little bit, get the rust off, and prime it and paint it with some copper paint. That actually came off easier than I expected. Turns out these rubber glass holders on either end have these little nubs that stick out the ends, and those push into holes in the metal, and that's what was holding them down. I simply pushed hard on the other side with some needle nose pliers and mushed these back through the holes, and they came right out, and I should be able to reuse them. I'm actually going to soak these in some Armor All for a few hours, which I've used in the past on rubber that was a little bit hardened with time, and it kind of revives it, so we'll see how that works out in this case. I carefully undid the string from the pulleys and just set it down in place, so I should be able to loop that back on without too much trouble, I hope. I can see all that rust in the back. It'll be much easier to deal with now. So these pulleys, they're held on by little cotter pin thingies, so I just pop these out. I should be able to get the pulleys off, set them aside. The pins I'm not going to mess with, they're riveted in place, so they're just going to have to stay on. I'll put a little tape over it to mask them off while I paint it. So I'm going to get the rest of these pulleys off and then get the rust remover going on this. After removing the rust with some navel jelly, I Sanded it down with 320 grit and then cleaned it off thoroughly with mineral spirits. Masked off the shafts that the dial cord pulleys run on and sprayed it with some filler primer. I'll let that dry a little bit, flip it over, spray the other side, let that dry for 10-15 minutes, give it a light sanding, and then spray on the Rust-Oleum Specialty Metallic Copper. Now that the radio is working, I want to go back in here and rebuild that electrolytic. So I have unsoldered all the wires and connections going to it, and I'm untwisting the twist lock tabs. So should be ready to pull out. Well, there's the cardboard sleeve that just came right off. The reason they use this is that the can is actually going through to these tabs down here, and that's soldered to the negative potential of this set, which is possibly going directly to one side of the AC plug. Remember, the chassis, the metal chassis on this is just floating. It's these black and white striped wires that are actually the negative rail, which goes right to one side of the AC cord. So, if that side of the plug is going to the hot, and you reached in and touched this capacitor, you could very well get shocked. Alright, there it is. Huh. So it's intact, didn't blow up after all. I bet what happened though is that this is leaky, and it got hot, which melted the adhesive, and this whole thing is unraveling. Since I've got my capacitor checker out, let's take a look. And then I'm going to open this up and try to rebuild it. Now, I was using these caps because I got a whole bunch of them, a really good deal from the Electronics Goldmine website. I'm not sure if both will fit in here though. Let's see. Yeah, I guess two will fit in here, but I'll have to stack them vertically and extend the leads down. But they're pretty good caps. 105 degrees Celsius, and they're rated for 450 volts, which is overkill in this case because the original was only 150. But mostly I work on TVs, and most of my caps that I buy are 450 volts, so they're a bit on the larger size. Anyways, I got a whole bag of these, so I'm going to use them. I was a little surprised to discover that this capacitor actually tests okay. So here I am testing the capacitance, and I get a full eye deflection, right around 40 or 50 microfarads. It's rated at 40 microfarad on both sections. And if I check for leakage, well, it's really not bad. Light goes out fairly quickly. And even at 200 volts, even though this is only rated for 150, I don't get any leakage. So I could probably put this back in and it would actually work alright. But the question is, for how long? I actually want to use this radio as soon as I get it back together. I've been using, can I get on camera there? Yeah, that white Philco 46420 I restored, what was it, a year or two ago? I'm going to put that back up on the shelf, and I want to put the Stromberg over there and let it play for a while. And I don't want to have to worry about a capacitor failing, so I'm going to go ahead and restuff it. I finished rebuilding the capacitor using the techniques that I've shown in other videos. Now I want to see what I can do about this cardboard cover. I think a little bit of wood glue and then maybe a fresh spray of flat black paint will take care of that. I finished restuffing the can, and I glued the tube back together and painted it with this acrylic flat black paint. Now it's ready to reinstall. I reinstalled the electrolytic capacitor and the radio is working fine. I thought I'd be able to finish the radio tonight, but I did spray this back plate with copper paint, and I think it'd be best to let it cure up overnight before I reinstall it. So it'll be a third part to this series, but it'll be a short one.